My project is on a Spotify data analysis. This analysis was inspired from a dataset on Kaggle, where someone was able to gather data from the top tracks of 2017. I've expanded this to include both my personal library and top tracks from other years as well. Starting off, what is Spotify? Odds are you've heard of Spotify before, or maybe even use it, but just in case, I'm going to give a brief overview of what it actually is. Spotify is a music streaming service that has 30 million songs and 70 million paid subscribers worldwide, and it offers recommendation services and radio options similar to Pandora, Tidal, AccuRadio, and other internet radio options. What's interesting is how it actually recommends a user certain songs. Spotify recommends tracks through values called audio features. These are generated via algorithms and then assigned to tracks to assist with determining what tracks sound similar. This process is completely automatic and proprietary, so we don't know how it actually works, but we do know what values get generated. The fields these values get generated for include categories such as danceability, which is how easy it is to dance to a song, energy, which is whether or not a song is high energy or low energy, valence, which is whether or not a song is positive and happy or negative and sad, and speechiness, which is how much spoken word is in a track. Rap songs get grouped into this last category. And these and other fields, such as release year and explicitness, can all get pulled through the Spotify API. These audio features can show us trends for the music that everyone listens to and also the music you personally listen to. And so the questions I ask are, what are those trends within my music and the music for the top charts? These questions are, what are the average audio features for my music, meaning what kind of music do I like? What are the average audio features for popular music? In other words, what kind of music do others like? How does my music compare then to popular music? And are there relationships between audio features? For example, does energy impact danceability? Now on to my methods. I'm going to show you how I was able to call these audio features and then upload them into phpMyAdmin. So this is a Python script I wrote to call the Spotify API. Up here is where I actually call the individual playlists based upon a config file for the individual tracks for a certain year. These are all the different fields that would then get written to a CSV file. And as you see on the left, the output was 7 different CSV files for each year and my personal collection on Spotify. So here is the end result on phpMyAdmin. I have one table called Spotify data. Initially, each of those CSV files created their own table. But thanks to this SQL command, I was able to create table Spotify data and then insert each of those individual CSV files into that one table. That made it much easier to connect to Tableau. Now on to my findings. These findings will answer the questions I posed earlier through the use of graphs, charts, and comparisons in Tableau. My first chart is my personal library broken down by year. This doesn't actually answer a question, but it was for me to give a demo for how I could organize my data. Each different color represents a decade, whereas each different bar represents a different group of 5 years. This tells me that I like newer music more than I like older music. Up next is a pie chart showing my personal library's top keys. As you can see, D is the most popular key, followed by E, A, G, C, and so on. This is interesting to me because I was assuming this would be evenly distributed, but as it turns out, some keys are used more often than others. These 4 charts show off comparisons between my personal library and the top charts on 2 different fields I pulled from Spotify. Those would be modal tendencies and explicitness. Modal tendencies are whether or not a track is major or minor, and as you can see, the top charts had more minor tracks in my personal list. Explicitness is whether or not it says bad words, basically, and as you can see, the top charts had more explicit music than my personal. These 3 scatter plots show off the relationship between energy and valence, danceability and energy, and finally danceability and valence. As you can see by the 3 different trend lines, as energy goes up, valence goes up. As danceability goes up, energy surprisingly goes down. And lastly, as danceability goes up, valence goes up. These 3 scatter plots show off the relationships between danceability, energy, and valence against popularity. Danceability goes up, popularity goes up. As energy goes up, popularity goes down. And as valence goes up, popularity kind of stays the same. Of these 3, danceability and popularity were the only 2 to have a significant relationship. These 2 charts show a comparison of popularity between my personal library versus the top charts broken down by individual years. The one on the left shows that my average popularity for my playlist is much lower than the average popularity for each top chart, which makes sense. On the right, it shows a comparison of the most popular songs in each list, and there I'm much more similar with every other year. Lastly, we have a comparison of many of those different audio features. The first chart shows that my music is generally more positive and cheerful than the top charts. Next, energy, mine is about the same with the top charts. Acousticness, mine is a lot more acoustic than the top charts. Speechiness, I'm a lot less speechy than all the top charts. And lastly, danceability, I'm a little bit lower than the top charts. I was able to draw a lot of different conclusions from this data and actually answer many of the questions I initially posed. For one, I like acoustic and happier music at the expense of popularity. This was shown by my personal library having higher acousticness and valence, but also being less popular. Dance and rap music is likely more popular with Spotify users than with me. This was shown by the top charts, having higher danceability, speechiness, explicitness, and having more minor keys. And energy, valence, and danceability are all related, and dancier songs are more likely to be popular. However, there were no relationships between popularity and energy and valence. That is the end of my presentation. Thank you for listening, and hopefully you found something interesting.